Hello, I'm Edward Tarte. This is another in my series of solution videos to some of my math challenge videos. The particular video here is my balancing act challenge, and here is how I presented that challenge in the original video. I have here some diagrams that represent 4 balance scales. 3 of them are in balance. The 4th one, as you see, has one of the pans empty. There are 4 kinds of shapes here: cubes, cylinders, cones, and spheres. I want to give you a close-up so that you can see clearly what is in each scale. And the question is, what should you put in the empty pan of that last scale so that it will be balanced? And you must put the smallest possible number of objects in that pan. Here's my solution. I need to determine the relative weights of the 4 shapes. I arbitrarily assigned to cylinder a weight of 100. Then I had X stand for the weight of a sphere, Y stand for the weight of a cone, and Z stand for the weight of a cube. Based on the 3 diagrams that were given, I wrote these 3 equations. For example, the first diagram had in the left scale, the left pan, 1 cylinder, 1 sphere, and 1 cone, and in the right pan, 6 cubes, which gave me the equation 100 plus x plus y equals 6z. And the next 2 diagrams gave me these other 2 equations. Then, for convenience and clarity, I rewrote each equation, as you see in the upper left-hand corner, so that I have an x column, a y column, a z column, the equal signs, and then the constant column. I then took the first 2 equations in the upper right-hand corner and added them, which gave me this equation: 2x minus 8z equals negative 200. To make it simpler, I divided it by 2, giving me this equation: x minus 4z equals negative 100. Next, I took the second equation in the upper right-hand corner and multiplied it by negative 3, giving this equation: negative 3x plus 3y plus 6z equals 300. Below it, I copied the third equation in the upper right-hand corner. I have made it so that the y column adds up to 0. You've got positive 3y and negative 3y. Adding those 2 equations gives this equation: negative x plus 7z equals 500. Now I have these 2 equations containing the variables x and z. I add them. I get rid of the x's because the x and the negative x add up to 0. And I have 3z equals 400. Dividing by 3, I have z equals 400 thirds. Next, I substitute that value of z into one of these 2 equations. I chose this one. And I solve it for x, and I get x equals 1,300 thirds. Then I put those values of x and z into one of the original equations in the upper right-hand corner. I chose the third one. I do that here, and I solve for y, and I get y equals 800 thirds. Summarizing my findings so far, I have these relative weights. Cylinder, 100, that's the weight I assign to it, that's 300 thirds. Sphere, 1,300 thirds. Cone, 800 thirds. Cube, 400 thirds. I want these ratios in simplest form. To do that, I divide by 100, which eliminates the zeros, and I multiply by 3, which eliminates the denominator's 3. And I'm left with these relative weights. Cylinder 3, sphere 13, cone 8, cube 4. Now to answer the question of the challenge, the last balance scale has, in the left pan, 4 cylinders. That's a total weight of 12. To balance that with the smallest number of objects, well, you could try 3 cubes, but that's 3 objects. You can accomplish it with just 2 objects by putting in the right-hand pan a cone and a cube for a total weight of 12 units. So that's my solution to my balancing act challenge. There are infinitely many ways to solve it. You can take any one of the 4 shapes, cylinder, sphere, cone, or cube, assign an arbitrary weight to it, and then write 3 equations, solve that system of 3 equations, and if you do it correctly, you are bound to come up with the same ratio of weights that I got. Cylinder 3, sphere 13, cone 8, cube 4. So that's it. Thank you for watching this solution video.